Hello and welcome. In this lesson, we will talk about some applications of the sine law and the cosine law. Remember that in order to solve right-angle triangles, we always use SOHCAHTOA. And to use non-right-angle triangles, we use the sine law and the cosine law. So if we have a triangle such as the one that I've drawn here, triangle ABC, where uppercase letters A, B, and C indicate the angles, and all angles are different from each other, and we indicate that on the diagram by drawing a different symbol at each angle. And the sides, lowercase a, opposite angle A, lowercase c, opposite angle C, and lowercase b, opposite angle B, indicate the side lengths. Then the sine law states that the ratio of each side with the sine ratio of the angle opposite to it will be the same throughout the triangle. The sine law allowed us to find an unknown using just two of the ratios in this double equation. And in order to find a side length, we needed to know two angles and another side. And if you wanted to find an angle, then you needed two sides and an angle. Now, we noticed or we found out and discussed some cases where the sine law couldn't be used because we were given either three sides or only one measurement in each ratio. So this is when we looked at a new way of solving a triangle using the cosine law. The cosine law can help us find the side lengths and the angles, but we use two separate formulas for each. So for the side lengths, we write c squared equals a squared plus b squared. So far it looks like Pythagorean theorem, but it's not, because we have to subtract twice the product of a and b and cosine of angle c. To find the angle c, we use sort of the same formula, but we discussed how we derive the formula on our own. And you can use this as a ready-to-use formula. So we start with cos -1, and then we write the ratio. It's a big fraction here. And since we're finding the angle c, then we subtract c squared at the end. And the rest of the terms will be a's and b's. So a squared plus b squared minus c squared divided by 2ab. And this is the cosine law. So today we are going to take a look at how to solve application questions using both sine and cosine law. Now remember that whenever we are solving trig problems or any geometry problems in general, a good diagram would make a huge difference on approaching the problem with the right strategy. So we want to go over some definitions on how to get oriented and master some tools to drawing the correct diagrams. I am going to start with the concepts that we have actually explained and mentioned recently, but just to catch your attention and make sure that everyone understands, I'm going over it one more time. So first of all, the angle of elevation. It's also known as the angle of inclination. The angle of inclination or the angle of elevation is the angle made between our line of sight when we're looking up and the horizontal line of sight. The horizontal line of sight is when we're looking straight. So we're not raising our eyes, goodness, or lowering them. So the angle of declination, which is also known as the angle of depression. That's not a very nice word, by the way. To call an angle. I prefer declination myself. So it's the angle that is made between the line of sight when we're looking down. So suppose you're looking at this, it looks like a flower, and the horizontal line of sight. Now, another important concept that we need to understand when drawing the diagrams is the bearings. The bearings are a way of describing the direction in 2D dimensions. So bearings are actually nothing but angles measured from the north line in the clockwise direction. hurry to write this. I'm going to try to do it fast. Okay, now, how do we draw the bearings? So what I draw in here is two lines perpendicular to each other. And what I was trying to describe in here is the north lines, north, south, east and west, so the compass, in other words. So I'm going to do this everywhere. Okay, should have done that before. It's okay. And we are going to draw the angle with a bearing of 50 degrees. Remember, we always start from the north line. And from the north line, which is this one here, we are going to have to move in the clockwise direction, which means that from here, we are going in the clockwise direction 50 degrees, so a little bit more than halfway towards east. And we're going to draw the line right here. So we're going to say that the direction will be this one here. Now, 50 degrees. In the next question, you can do the next example on your own because you're able to. For 72 degrees, again, we start from the north line. Here is the north line. We start from here and we go 72 degrees in the clockwise direction. And then we draw the line or the direction from the origin. So this would be 72 degrees. Now, a bearing of 250 degrees, again, start from the north line. I know it's repetitive, but that's how we remember things better. And we go from the north line, 250 degrees, so 90, 180, and now I stop for a moment, take a deep breath, and think from 180 to 250, I have 70 more degrees to go, so I stop here. And I'm going to say that this would be the direction then. So this would be a 250 degree bearing. For 310 degrees, again, north line. You may want to stop the video and try to do this on your own. And then we go 90, 180, 270. We stop there and we think we need 40 degrees to hit 310. And here we go. Okay. Now, this is how we measure angles or how we show degrees by the direction by using bearings. And bearings are the more popular way of showing direction, and that's what the sailors use usually when they're in the open sea. But there is also another way of indicating direction, which is very similar to what we are doing, so using the compass. And I'll show you the first one. You can measure the angle by using the two lines on the compass. What does that mean? So we can look at 50 degree bearing as an angle that is measured from north going towards east 50 degrees. So you read it left to right. In the same way, we can actually describe this angle or this bearing of 72 starting from north 72 degrees going towards east. Now, in the next example, we have 250 degrees. So what we are going to do is just simply use the acute angle. And we're going to say that here we have 180, 90 actually, which makes 180. And then this one here would be 70 degrees. So we are going to say that measuring it from south, we go 70 degrees towards the west. So from south, you go 70 degrees towards the west. And last, we have 90 degrees here, another 90, another 90, that's 270. So we had to go, to hit 310, we had to go 40 more degrees. And we're going to say from west, we go 40 degrees towards north. Now, the same direction can be indicated or shown by using the other acute angle. So, for example, you can look at this angle here, And we can say that another way of describing the direction is starting from east, you go 40 degrees towards north. So starting from east line, that's your first letter here, go 40 degrees towards north. So towards north. The next one would be this angle here, which is 90 minus 72, that's 18 degrees. So we can say starting from east, we can go 18 degrees towards north. In the same way, we can look at this angle to show the direction or to describe the direction. And we're going to say starting from west, we have to go 20 degrees towards south. And in the same way, we can look at this angle here and say we start from north, go 50 degrees west. Okay? So this is how we describe angles on 2D. Now, another thing that I want to mention before we start with our word problems is how do we make the decision whether we have to use the sine law or the cosine law. And here is a strategy that I've shared with you in the past, and I want to review it again. So whenever we are trying to solve a triangle, a non-right angle triangle, we first try to check and see if we can use a cosine law, because there is only two cases when we use cosine law. So case number one is when we are given two sides of a triangle and we are also given the angle in between. Remember that I called this the crocodile's mouth, where the two sides kind of represent the jaws and the angle here between the jaws, right? So that's when we use the cosine law. And normally what you would use in here is the formula for the side length, which is c squared equals a squared plus b squared minus 2ab cosine of angle C. The second case when we must use cosine law and have no other choice is when we know all the lengths of the triangle, the side lengths of a triangle, and we don't know any of the angles in the triangle. So in this case, we have to use the cosine law for the angle. And the cosine law for the angle states that angle would equal inverse cos. And again, if you remember again, we just mentioned the big fraction, take away c squared, because that's the angle C you're measuring, and the rest of it is filled with a's and b's in this format, okay? I think that we're now ready to solve some application questions. We have two fire towers that are located 10 kilometers apart. So here we go. The two fire towers are 10 kilometers apart, and I'm going to call them towers A and B. Now, exact locations of fires are found by measuring from each tower the angle between the fire and the other tower. Okay? And sorry about this here, and the other tower. Now, a fire has been located at an angle of 47 degrees measured at Tower A and at an angle of 62 degrees measured at Tower B. So how far is the fire from each tower? Here goes the fire at the point F. So from B is 62 degrees, okay, so the angle should be, or the fire should be closer to B, okay? And that's the fire, letter F right here. And what we want to find out is how far the fire is from each tower, okay? So we are given the angles. There are 47 from Tower A, and from Tower B, 62 degrees. What we need to know is the lengths. So the things that I want to do is, first of all, sort out what information I have or I'm given. So I know that AB would be 10 kilometers, so I'll write this down. And I'm also given two angles in a triangle, and whenever I'm given the chance, I will find the third angle if possible. And that seems to be the case in here because we have two angles, and we can simply find angle F by using the sum of the angle in a triangle theorem. So 180 minus 62 minus 47, which would give F. How much room in here? 109. So 180 minus 180, and 80 minus 9 is 71 degrees. Okay, so there goes angle F. And whenever I find new information, I like to circle it, because in this way I can relocate it when I need it in my next steps. And I also want to write it here on the diagram, because when it's on the diagram I can make the connections between the information given and my diagram more easily. Okay, so now the next thing I want to do is label the sides. And I'm going to label the sides in relation to the angles opposite to them. So it seems that I have the side A, lowercase a, opposite angle A, lowercase b, opposite B, and then we have lowercase f in here. Then the next thing that I want to have to do here is think, what formula do I use? So do I use the formula for sine or cosine law? So I examine first if it is one of the cases for cosine law. Remember, cosine law is two sides and the contained angle. So I don't even have two sides, so that's not the case. The other case is when you have all three sides and none of the angles. So it's neither case, which means, or which leads me to believe that sine law should be the way to go. Hey, that rhymes. So let's write the sine law here. We have A divided by sine of angle A equals B divided by sine of B, and that equals F divided by sine of angle F. And from here I will substitute everything and anything I have. So I don't have A, I want to find A actually, divided by sine of 47 equals B. Again, I don't have B, I want to find B, over sine of 62. And that equals F, which is 10. Thank goodness I have F. And that's divided by sine of 71. So I have to think now, what side do I have to find first? Well, it's optional because it's easy to kind of see it, or it's easily seen, I was gonna say. So we have to first locate the ratio where we have both numbers in. So we have the 10 and we have the sine of 71. So that's a ratio we must use for sure. The next ratio you want to use is whichever variable you want to find. So I am going to start with side A. So I'm going to write the equation here on the side. To find A, I'm using A over sine 47 equals 10 over sine 71. Whenever you use a sine law, remember you have to cross multiply. That's kind of easy in here because it's very straightforward. We have only one fraction in each side of the equation, and we're going to have A sine 71. Always remember to multiply by the variable A sine of 71 first. And I do that only because I like to keep my variables on the left side of the equation. And then 10 sine 47 will go to the other side. Now we need to isolate A, that's our unknown, which means we need to divide both sides by sine of 71. This is quite an easy calculation to perform in your calculator in a single step. Just remember to place brackets around 47 when you calculate it. I will show it to you how I do it on my calculator. So 10 sine 47 over sine 71. 10 times sine 47. Remember, here you have to close the brackets, because if you don't, then whatever you input in there will count as the angle whose sine ratio we're trying to find, all right? So sine of 71 divided by sine of 71. Close the brackets, enter, and I got here 7.734 or 7.7. So I'll write that down. So 7.7 will be the side length A. Meters. And then I move on to finding the side length B. For side length B, what I'm going to do is use this ratio obviously here that contains B, and I'm going to use this ratio that has both numbers in. And write that down. So to find B, you go B over sine 64 equals 10 over sine 71. Again, cross multiplication. And we have B sine 71 equals 10 sine 64. Isolate B, and then we get to divide by sine 71 both sides, and then B would equal, again we're going to do the same thing on the calculator, 10 sine 64 over sine 71. So 10 times sine 64 over sine 71. Close the brackets, and here we go, we got 9.5 there. So the value of B is 9.5 meters. So here are both our answers, which I will box up. But remember that this is a word problem, which means that we need to write a therefore statement. So in this case, whenever we solve word problems, we start this therefore statement from the question asked, and the question asked is how far is the fire from each tower to one decimal place. So we're going to say the fire is 7.7 meters far from tower A and 9.5 meters far from tower B. Okay, so moving on to another application question, which is our last application question. We have a 1.5 meter pendulum which swings through an angle of 6 degrees. How wide is the swing to the nearest centimeter? So imagine a pendulum here, right? And it's swinging back and forth. So it's going this way and this way. Now, I exaggerated the angle a little bit just to make the diagram clearer, but we are told that the angle, the swinging angle here is only 6 degrees, so a lot smaller than it looks on my diagram. Now, remember that the length of the pendulum would be the same, doesn't matter in which direction the pendulum is swinging, to the left or to the right. So, which makes these two sides equal to each other. Now, since we're trying to find the width of the pendulum, we shouldn't focus on this arc. We just have to focus on this one here. That's the width of the pendulum. So the width of the pendulum is that side that is opposite angle 6. I'm going to complete my diagram by giving each angle a name because I now see a triangle, and I will call this a triangle A, B, C. And then I'm going to say that this angle here is actually equal to this angle here. So I'm going to leave them, or I'm going to give them the same symbol. And angle C is obviously different. We have a lot of options in here. So we can easily find angles A and B because we know that they are equal to each other. But we're going to leave it at that because we're going to use here a special formula actually. So this would be lowercase a, lowercase b, and lowercase c goes right here. So lowercase a would be 1.5 meters, and so will lowercase b, 1.5 meters. So now we're thinking, which case is this? Remember that in this case, we're given two side lengths and the angle in between. And when that's the case, we use the cosine law for the side, the missing side. So we'll write that down. We're going to say c squared equals a squared plus b squared minus 2ab cosine of c. Substitute all the numbers. We have 1.5 squared plus 1.5 squared minus twice 1.5 cosine of 6. And it's a fairly easy calculation to do in your calculator in one step. So here we go. I go 1.5 squared. I'm going to clear everything actually. So 1.5 squared plus 1.5 squared minus 2 times 1.5 times 1.5 and then times cosine of 6. And you enter and we get this funny looking number 0.02465. So remember, we haven't found c yet because we need to square root both sides of this equation in order to get to c. And we're going to say that would equal. And what I usually like to do is, which is kind of a smart thing to do actually, and I encourage you to do the same, leave the answer in the calculator so if you need to use it in your next step. So in my case, I have to square root that answer I got before. So instead of typing the rounded answer, I simply enter that answer by pressing second function and the negative sign on my calculator. That's where my answer button is hiding. And then the calculator takes the whole number there, so my answer will be more precise. So 0.157, so 0.16. So we're going to say that c is 0.16 meters. And it is asking to the nearest centimeter. So we're going to say that that's 16 centimeters then. So therefore, we're going to say that the width of the swing is 16 centimeters. One thing that I want to bring to your attention is the unit measurements in here. So how do we deal with the unit measurements? Now, there are two options. Option number one would be converting the length of the pendulum into centimeters right away, and then you will get your answer in centimeters at the end. Or you can leave your answers in your measurements in meters, and when you get your final answer, don't forget to convert it. But most importantly though, whenever you are finishing up with a problem, always reread the question very carefully to make sure that you have answered the question asked. That was it for today, and I hope everything made sense. Bye for now.